It all started when Edison invented the first incandescent lamp in 1880 and Tesla designed the first alternator in 1891. These were the first steps of what we now know as direct and alternate current. Electricity is one of the most important energetical sources we have nowadays. In order to use it, it has to suffer a lot of transformations before it gets to our house. It all starts with the generation of the electricity. So as to do it, there are multiple ways. On the one hand, we have the conventional power plants. These are non-renewable plants and there are three types. The first ones are hydroelectric plants. This uses the potential energy of the water retained in a dam to transform it to kinetical energy in order to move a turbine and produce electrical energy. It is CO2 emissions free, but on the other hand alters the biodiversity of the area as well. The next ones are thermal power plants, where different fuels are burned so as to heat the water and move a turbine. However, it produces big amounts of CO2 emissions. And the last ones are nuclear plants, which work with the fission of radioactive atoms to produce heat and move a turbine to produce electricity. It doesn't emit CO2 gases but leaves behind a lot of radioactive materials that are very difficult and expensive to get rid of them. However, there are other types of plants that don't have CO2 emissions, and these are what we call renewable power plants. First one is wind energy. This uses the energy of the moving wind in order to rotate a windmill and produce energy. It is very flexible but very difficult to forecast. Next ones are the ones that absorb the solar energy and transform it. On the one hand, the solar thermal energy plants reflect the radiation of the sun into a boiler that heats up a fluid and produces energy. On the other hand, photovoltaic energy plants transform solar energy into DC. Finally, there are other minor types of renewable plants. For example, geothermal, that uses the crushed energy of the underground water, marine energy, that uses the energy of the tides and waves, and biomass by burning bioresidues.
Electrical transmission. The purpose of transmission is to connect large energy production sites with consumption centers, such as big cities or factories. In order to achieve this goal, high-voltage power lines are distributed all across the world. These lines carry huge amounts of energy and work in very high voltages, sometimes up to 1000 kilovolts, for a simple reason. The power loss in a line is determined by this equation. As we can see, the power loss is proportional to the resistance of the line and to the square of the current intensity. In order to minimize the current intensity and thus the power loss, we can raise the voltage, maintaining the same power. These electrical highways are difficult to install and very expensive, so to make electricity transportation cheaper, big companies use aluminium for conduction. This metal, despite being less conductive than copper, has a much lower density, which results in a lower weight in the lines and allows these enormous posts to be farther apart, cheapening the cost of the line. The transmission lines and substations are measured, operated, and protected by some groups called TSO, or Transmission System Operators, who act in real time to ensure their optimal working conditions. In Spain, the TSO is called REE, which stands for Red Eléctrica de España. Electric distribution is the part of the electric grid where the electric energy is delivered to the consumer. For this purpose, the voltage in the lines is stepped down from high voltages and is divided to medium voltage lines. Each of these delivers electricity to a smaller area. Then, the voltage is stepped down and split once again, creating low voltage lines. These lines are responsible of supplying energy to residential areas for its consumption, and are the ones we usually see in cities or towns.
Supplying the demand. Along the last decades, electric supply demand has suffered a sustained and pronounced growth. Electric consumption indexes are industrial and social development indicators. For example, here we have the chart of China, which shows a huge growth on electric generation, which is mainly generated by fossil fuels. In the case of Spain, we can see that the generation was growing until 2007, when there was a big crisis. What's more, the chart shows that in the last 15 years, there has been a very big growth in the electricity generated by renewable sources. Finally, here we have the chart of Syria, whose electricity generation is based on fossil fuels. It clearly shows the effects of the civil war that started in 2011, and how this event has reduced drastically the generation to levels of 1995. There are two concepts to measure demand: power and energy. Power is the instantaneous value of the consumed energy, while energy is the power consumed over time. But energy consumption is not the same along the year. It's highly dependent on the climate. For example, during summer, energy consumption increases a lot, mainly due to the use of air conditioning. And something very similar happens in winter, because of the heating. Demand profiles show the demand of energy during a day. In a weekday, the profile is like this, with a valley at 4 a.m. and two peaks, one at noon and the other one at dinner time, around 10 o'clock. However, in a holiday, there is a big valley at 4 a.m. and a big peak at 10 p.m. Then we have a secondary peak at noon and a secondary valley at around 6 p.m. Problems and future. The main energy problems are the following 5. Serious environmental problems, the significant supply-demand growth, the fact that the infrastructure has reached its lifespan and needs a reparation, the opening of the markets, and the reduction of greenhouse gas emissions due to climate consciousness. In order to solve these problems, there are 3 ideas. The first one is a smart grid, a grid that allows a bidirectional flow of both electric power and information. Then, virtual power plants, which have the objective of aggregating many small and geographically dispersed generation units. And finally, developing efficient transmission technologies such as FACTS and superconductors.